Hello, I'm Mrs. J, and today we're going to look at the applications for the derivative. And one of them is the tangent line, because when you take the derivative, you're finding the slope of the tangent line. So if we want to find the equation of the tangent line, and we're given an x value, we can find the point for that x value by plugging it into the original problem. So to find y, it's 2x, or 2 to the 4th, minus 5 times 2 to the 3rd plus 2. Just plugging it into the equation. And get 2 times 2 is 14. 16 minus 2 times 2 is 4 times 2 is 8. 40 plus 2, which is a negative 22. So our point is 2, negative 22. So now we have a point, we need a slope. To find the slope, it's just the derivative. So we need to take the derivative. For the derivative, we bring the 4 down. 4x subtracting 1 from the exponent, we get a 3. And then 3 times 5 is a negative 15x squared. 2 is a number or a constant, so it goes to 0. So this is the slope of the tangent line. We want the slope of the tangent line when x is 2. So we plug in 2. 4 times 2 cubed minus 15 times 2 squared. 2 times 2 is 4 times 2 is 8 times 4 minus 15 times 4, which gives us a negative 28. So our slope is a negative 28. To find the equation, y minus y1 equals m times x minus x1. We have y minus, our point is right here, so y minus a negative 22, which is just a plus, equals our slope times x minus 2 from our point, x1, y1. So y plus 22 equals, distributing the 28, 4, 5, 56, and then subtract the 22. So you have y equals a negative 28x plus 34. So this is the slope of the tangent line, or the equation of the tangent line. The slope is negative 28. Find the x values where the tangent line is horizontal. Where the tangent line is horizontal is important, because if we had a graph, notice the horizontal line, because the tangent touches at one spot. If you're finding where it's horizontal, you're finding your max and mins. So it's a very important concept. Most of the story problems will deal with it. If the line is horizontal, the slope is 0. So we want to take the derivative and set it equal to 0. Those x values are our highs and lows. So first we want to find the slope by taking the derivative. 6x squared. This is a 1, so it's plus 9. X to the 0 drops out. Wait, I think I missed a... This should be squared. Sorry, this one should be squared because this is x to the first, so it's 18. X minus 60. This one was to the first, so it'll be a minus 60. X to the 0 drops, and the constant goes to 0 also. Set it equal to 0 and solve. Before factoring, or you could use the quadratic formula, but we could just divide by 6. Sorry about the dog. And it is factorable. We'll factor using 5 times 2. We want a positive 3, so the 5 will be positive. X plus 5, x minus 2. So x gives us negative 5 and 2. So with these two values, that's where you have the highs and lows on the graph. Let's try another one. Find the equation of the tangent line. Now this one uses the quotient rule. So it's the bottom times the derivative of the top, and the derivative of x is just 1, minus the top times the derivative of the bottom. The derivative of x minus 2 is also just 1, all over the bottom squared. And we were given our point, and we want to find the equation of the line, so we need to, I would simplify this first. So we want to plug in the 3. But you could simplify first. This is the derivative. X minus 2 distributing the 1 minus x over x minus 2 squared. Simplifying that, we get the x's drop out, negative 2 over x minus 2 squared. And then we're going to plug the 3 in. Three minus 2 is 1 squared is 1, so our slope is negative 2. Y minus y1 equals m times x minus x1. Our point was 3, 3, and our slope was a negative 2. Distribute the negative 2 and add the 3. And this would be the slope of the tangent line. Or the equation, the slope is negative 2. Find the values of x where the derivative is equal to 0. Remember, the derivative equals 0. This is our horizontal asymptote. So you can say it this way, or you can say where this tangent line is horizontal. Both mean the same thing. So we need to take the derivative. Derivative is the bottom times the derivative of the top. Bottom is 4x squared, derivative of the top is just 1. Minus the top times the derivative of the bottom is 2x all over the bottom squared. Simplifying it, distributing the 1, we have x squared plus 4. Here we're distributing a negative 2x. We have negative 2x squared plus 4x all over x squared plus 4 squared. So we have a negative x squared plus 4x plus 4. Find the values where the derivative is 0. When you're setting a fraction equal to 0, the only way it will equal 0 is if you set the top equal to 0. I just want to make sure. Bottom derivative top minus top derivative bottom. Negative 2x squared plus 4x. Okay. This is not factorable. Oh, I'm going to multiply through by a -1. So then we have x squared minus, let me move it up one, x squared minus 4x minus 4. It's not factorable, but you can use the quadratic formula. Negative b plus or minus the square root b squared minus 4ac all over 2a. 16 and 16 is 32. So we have 4 plus or minus the square root of 32 over 2. And 30 over 2, 4 times 8. Which is 4 plus or minus 2 radical. Oh, wait, I could have went with 16. I'm going to go with the bigger one, 16 times 2. Which will give us 4 radical 2. And then 2 divides into both of these. So it's 2 plus or minus 2 radical 2. And then if they want the decimal, you just plug those in. So this one was not factorable, so we used the quadratic formula. 32 had a perfect square of 16 in it. 16 times 2. The 16 comes out as a 4, and then 2 can go into both terms because there's 2 terms on top. And that gives us this. One more. Demand. Demand is Q equals 5,000 minus 100P. P is your price and Q is your quantity. In most cases, we want this solved for P instead of Q because they want us to find the revenue function, and revenue is in terms of Q. So we need to solve this first. So you want to bring the 5,000 over. And then divide by 100. So we have 1 over 100Q minus 50 equals P. So R of Q, remember it's your price times your quantity, or Q. So we take this times Q. Which gives us this for our revenue. Marginal revenue. Marginal means you take the derivative. It's telling you the rate of change of the revenue. So we want to take the derivative. 2 times 1 over 100 is 1 over 50. Put it over here. Minus 50. So the derivative, 2 would be 2 over 100, which reduces to 1 over 50, q to the first. And this is to the first, so it leaves a negative 50, q to the 0 drops out. Then we want to find the marginal revenue at these values. So we'd plug in 1,000 into the equation. We're putting, delete these, 1,000 200 or 2,500 gives us 0. 3,000 gives us 10. We know our revenue is a parabola. And this parabola is going this way. So this 0 is telling you where you're increasing and decreasing change. This is also telling you over here it's going down because it's negative, and over here it's going up because it's positive. So they're telling you the rate of change of your function. It's also telling you when you plug in 1,000, it's telling you if you go one more, the 1,001 unit will be a loss of 30 in your revenue. If it's in dollars, it'd be $30. This is saying going one more, there's no change. And this is saying the 3,001st one would be an increase in revenue of $10. So it's telling you how it changes at that point or the following one. Okay, we need our revenue function, which is this one. We're given cost and we want to find P of X, P of Q. Remember, profit is revenue, which is 1 over 100 Q squared minus 50Q minus the cost, 3,000 minus 20Q plus 0.03 Q squared. Since this isn't a decimal, I'm going to put this in a decimal. 1 over 100 would be 0.01. That way they're easier to combine. When we combine these, remember this negative has to distribute through, so this is a negative. And a positive is a negative 0.02 Q squared. This becomes positive, and this negative is a minus 30Q minus 3,000. Because this negative can become a positive and make this one negative, this one positive, and this one negative. So this is our profit function. Marginal profit, you take the derivative. When we take the derivative, we get a negative 0.04Q minus 30. And they wanted us to find the marginal profit, how it's changing at 500, 815, and 1,000. So we plug those in to the derivative. And we plug them in. At 500, we get a negative 50. At 815, I got 62.6 negative. And the last one, negative 70. So this profit, the rate of change keeps decreasing. That's everything for these two sections.